Ladies and gentlemen, welcome to the end of Unit 7. We've been all about polynomials this entire unit, so we're finishing off by putting everything together and just straight out solving polynomial equations. So you need to be able to factor polynomials and solve by factoring. Yes, factoring is back again. It never seems to go away, so we need to kind of stay strong with that and make sure we know what we're doing. Now, let's kind of get into it. So, factor the following quadratic equations. So, if I look at this first one, this is just an old school A times B situation. So, I'm going to take 2 times 15. And for those of you guys that draw your X, that's fine. Negative 30 and negative 7. I need to start playing around with what multiplies a negative 30, but adds up to negative 7. So when I do that, I am going to come up with negative 10 and positive 3. Now, my next step is to rewrite the middle term using negative 10 and positive 3. Then, depending on how you do it, or depending on what your priority is, I like to draw a box. Some people like to draw, like just put parentheses around. I draw a box and then I go across. What's in common? Well, 2x. What's in common here? 3. Go down, what's in common? X. Go down, what's in common? Negative 5. So my factored answer is going to be 2x plus 3, x minus 5. So all I did, put every term in a box, go across, across, down, down, what's in, and go for greatest common factor, and that gives me my answer. For 2, I'm hoping you're looking at that thing going, well, I can't factor it like I just did because that's going to be different, and you would be right. So this is where you do first rule of factoring, and that is pull out everything in common. So between 25 and 15, I can pull out 5. A cubed and a squared, I can pull out a squared. B to the 5th, b to the 6th, I can pull out b to the 5th. And then I write what's left, so that's going to be 5. A plus 3B. There's my factored answer. First rule of factoring, straight GCF. What can I pull out of there? This is actually called a difference of two squares. And the short answer for a difference of two squares, a difference of two things squared, is that's just A plus B, A minus B. So x squared minus 81, that's going to be x plus 9 times x minus 9. A lot of people like to try and tell me it's x minus 81 and x plus 81. That's a very popular wrong answer. Okay, it's got to be what multiplies to get 9 back. So here is what I should look at now when I've got a difference of two squares, which we just talked about, sum of two cubes, difference of two cubes. I would make sure that I've got this handy and nearby. All right, so when you factor polynomials, you take out the GCF first. First rule of factoring, pull out what's in common. All right, then you go from there. So now I want to remember sum of two cubes, two things cubed. You add, subtract, add. Difference of two cubes, subtract, add, add. So if you look, the sign pattern goes like this. So you go, for this one, same, opposite, add. For this one, same, opposite, add. So let's start looking at this here. So this is something cubed, this is something cubed. Okay, so this is a sum of two cubes. All right, this is like saying x cubed plus 5 cubed. So that's going to be x plus 5 times x squared minus 5 times x plus 25. That is my factored answer. And I can't factor that anymore. I'm done there. For number 5, this is going to be a difference of two cubes. And I know that because this is going to be 2x cubed and 27 is actually 3 cubed, raised to the third power. So when I factor this, it's going to be 2x minus 3. Then I go a squared, which is this thing squared, so that'll be 4x squared, plus 2x times 3, so 6x, plus 3 squared, which is going to be 9. There's my answer. Boom, right there. So this is going to be something to have very handy. All right, so let's solve it completely. So factor completely. So this is going to be a squared minus 49, so a difference of 2 squares. So that's going to be a squared minus 7 squared. So it's going to be a plus 7 times a minus 7. There's my answer. Now, 7 is going to pose kind of a fun little problem. Here's why. I'm going to treat this exactly like something squared minus something squared. X squared squared minus 9 squared. So that becomes x squared minus 9 and x squared plus 9. But take a look at this one now, because x squared minus 9 is actually once again a difference of 2 squares. This can be thought of as x squared minus 3 squared. So I can keep factoring that into x plus 3 and x minus 3. So this would be my fully factored answer right there. So just be aware that that thing can come up. So here, just because I have x to the fourth in front doesn't mean I change anything. All that really matters is that, all that really changes is that instead of an x out front, now I have an x squared. So I need what multiplies to 50 but subtracts to negative 23. Well, that would be negative 25, and that will be positive 2. Okay, 25 and 2. But notice now that this one is a difference of 2 squares. So that would be x plus 5, x minus 5. And then I just bring along the x squared plus 2 because I can't do anything with that. So this is my answer, x plus 5, x minus 5, x squared plus 2. Oh, stay there. Go over there too. Okay, so now with number 9, same kind of idea. All right, x squared and x squared again. So it multiplies to negative 63 but adds up to 2. Well, I'm going to go minus 9, or plus 9 minus 7. Now I can't do anything with this. It's not a difference of 2 squares because it's addition. That would make it a sum of 2 squares, and I can't do anything with that. So that is technically as factored as you can get it. Okay? This is not a difference of 2 squares. It is a sum of 2 squares. So for quartic equations, so same kind of idea. So quartic equations, you want the factors of C with sum of B. So this doesn't change here. All right? So all it is becomes x squared plus something, x squared plus something, and then you just set them equal to 0 and solve it, okay, however you can. So if I'm looking at, let's start with 10. So this one factored is just going to be x minus 7, x plus 2. Factors of 14, that subtract to 5. 7 and 2. All right, so equals 0. So I set each part equal to 0. So x equals 7, x equals negative 2. All right, there's my solutions. All right, for 11, same kind of idea, follow the same kind of rule, but here is what's going to happen. So I get x squared, but 1 multiplies to 36 adds up to negative 13. So I'm going to go minus 9 minus 4. Ooh, this is going to be interesting because both of these are a difference of 2 squares. So let me do this. For this one, x squared minus 9 can become x plus 3 and x minus 3. And let me change color here. X squared plus 4 x squared minus 4 can be rewritten as x plus 2 and x minus 2. Now realize they're all still equal to 0. So that means x plus 3 is equal to 0, x minus 3 equal to 0, x plus 2 equal to 0, x minus 2 equals 0. So my answer, negative 3, 3, negative 2, 2. There's all my answers. Negative 3, 3, negative 2, 2. 4 solutions, which is kind of what I want. So now, that is a good problem, but that's also a problem that shows how kind of deep this thing can get. So if I look at 12, what multiplies at 225 but adds up to 34? So I want to start playing around with factors of 225. So 225, well, it's 15 times 15. 225 divided by 5 is going to be 45 and 5. So 225 divided by 9 is going to be 25. So 25 and 9 is going to be what I want. So I'm going to have x squared minus 25 and x squared minus 9. Now it's kind of like that similar situation, the problem we had up above. This is a difference of two squares, as is this. So this becomes, let me skip down here through the writing, x plus 5, x minus 5, which you've seen a couple times already, x plus 3, x minus 3, still equals 0. So that means each little part equals 0. So that means my answer is going to be negative 5, 5, negative 3, 3. So my solutions here, negative 5 plus or minus 5 plus and minus 3. There's my answer. That's my solution to that problem. So now for 13, sum of two squares. So that means I go x, or sum of two cubes rather. So that means I go x plus 4. Then I go x squared plus 4x plus 16 equals 0. So now, to solve this, I'm going to set this part equal to 0. Sorry, hold on. Back up. That's going to be a minus. So that's going to be x plus 4 equals 0. So x equals negative 4. And then, for this one, I can't factor it. You know, it's not factorable. So what I could go through is I could run quadratic formula. I could do that. I could do 4 plus or minus square root 4 squared minus 4 times 1 times 16 all over 2 times 1. The problem with that is this is going to be negative underneath. So that's going to be 16 minus 64. This is going to be a negative. So that tells me that it's not real. Okay, so negative 4 is going to be my only real solution. All right, this underneath here is not going to be real. So that's where I'm going to stop because the other two are not going to be real. All right, so play around with this. Take your time. It's pretty elaborate, but there's a lot of nuances to it. So make sure that you're careful and make sure you come talk to me with questions.